Hey guys, this is Eggy with the Math Egghead program, and this video is about balancing chemical equations. Now, I did have one of my lovely viewers, Joanne, who went ahead and sent me a comment and explained that she was having some issues and wanted to know if there was a way to balance chemical equations instead of using the trial and error process. The answer is yes. There is many ways that you can do a problem like this. And then I do have even some colleagues that will go ahead and scan the problem and be able to change the coefficients. But is that something that a beginner can do? Absolutely not. As you guys can see here on this particular problem, even I had to do it a couple of ways because I wanted to know if there was an easier way to think about this problem and solve it. But as we can see here that there was only one way to think about it. But in chemical problems, in chemical equation problems, there isn't a way for us to just automatically know when we're looking at a particular molecule that the coefficient or the subscript is going to be a particular number. There's no way for us to do that without actually doing the trial and error. As I said before, when doing chemical equation problems, number one, you do have to be very familiar with the atoms and molecules that you're dealing with. Number two, remember about the rule, coefficients you're able to change, subscripts you are not. And third of all, polyatomics. Now, polyatomics can be very tricky because as you can see here, usually if you see something like nitrate, you see nitrate here. I'll go ahead and highlight that real quick. Nitrate here, my first instinct would have been to keep them together and don't consider them separate. But in this particular redox problem, we do separate them into nitrogen, oxygen. Now, let's go ahead and try to solve this problem here. So I want to go over the rules real quick again. As I stated before, when dealing with balancing chemical equations, the first rule is that you do not change the subscripts. I'm highlighting the subscripts so that you guys can visually see what that looks like. The only thing that we're looking to change is the coefficients, which are here, right here, and this is supposed to be just a little highlighted space, not a number. So here, the front, the front, the front, in the front, and in the front, right where the pink is, right? Those are where our coefficients should be. You never change the subscripts, okay? Now, also, the second thing that I wanted to specify is that the polyatomics. When dealing with polyatomics, usually you will go ahead and keep them together when you see them, because as you can see, especially when the molecule doesn't break, meaning that, for example, let's say you saw the nitrate, go ahead and the product ended up being nitrate, ended up being with copper, and then oxygen only ended up with being with nitrogen. That's when you see that the polyatomic is no longer a polyatomic ion because it has now attached itself to different atoms. So when you see that they're together, usually you keep them together when doing the trial and error process. But as you can see, they are together, but this problem does not allow for you to just think of them as a separate entity. You must go ahead and consider each atom separate, like copper, nitrogen, hydrogen, and oxygen. And my last rule, which is a bit of a suggestion, is that usually when balancing equations, we do like to keep oxygen and hydrogen at the end, only because they tend to go ahead and they're able to pair up and bond with different molecules and atoms, and they can get a little tricky at the end. But as we can see on this problem, we'll go ahead and try to deal with this. Alright guys, so I'm just going to keep the subscripts highlighted only because I want you guys to know never to change the subscripts. And when you see yellow, it's like danger zone. Don't touch that. It's hot. Don't do anything with those particular subscripts. Okay, so let's start off here. We have copper, nitrogen, hydrogen, oxygen. Here we have copper, nitric acid, copper 2 nitrate. We have nitrogen dioxide, and we have H2O water. So here, let's start off first. How many coppers do we have? We have 1. Nitrogen, we have 1. Hydrogen, we have 1. Oxygen, we have 3. Here we have 1 copper. Nitrogen, we have 2 here and 1 here. Remember that this particular 2 here goes to the oxygen and it goes to the nitrogen right here. Because of these parentheses, you have to be very attentive to if there is a parentheses or not. Just like there wasn't a parentheses here, so we knew that this 3 belongs only to the oxygen. Okay? Okay, guys. So we see that there's 2 nitrogens here and 1 nitrogen here. So we have 3 altogether. Hydrogen, we have 2 hydrogens, and oxygen, we have 6 here because it's 3 times 2. Remember the parentheses. This 3 belongs only to the oxygen. So it's 3 times 2 is 6. So you have 6 here. This 2 belongs to the oxygen. So it's plus 2. And then here there's only 1 oxygen. So altogether we have 9. Okay. Now, my personal experience with this chemical equation, I always like to do, like I said, everything but hydrogen and oxygen. But I saw here that in this particular problem, for it to go a little smoother when you are balancing the equation, you would have to go to copper is already balanced, right? Because we already have 1 to 1. Well, the easiest thing now is to go to hydrogen because hydrogen has the smaller number that we can deal with. It's an even number. It's a smaller number than 3. Usually when you are dealing with an odd number, the coefficient is going to be like a 1.5 or a 2.5. And then you have to go ahead and multiply the entire equation by 2 at the end so that you can get whole numbers. But that's not what we're trying to do. We're trying to focus on balancing this equation as smoothly as possible here. So hydrogen, we have here 2, and here we only have 1. So I am going to go ahead and enter the 2. Now that changes everything on this particular side, on the reactant side. So 2 hydrogen, that's going to change 2 hydrogen, 2 nitrogen, and now we have 6 oxygen. Okay. The next thing we are going to do is that there are 2 nitrogens on the reactant and 3 on the product side. So, and also we have 6 oxygens on the reactant, 9 on the product. So, just quickly, because I'm sure that in chemistry you guys are all able to use your calculators. If we wanted to go ahead and balance, 3 divided by 2 is 1.5, 9 divided by 6 is 1.5. So either way you wanted to balance, you could do it that way, right? So if you wanted to go ahead and balance the oxygen, it wouldn't be as easy as that because as you can see, we have an oxygen here, we have an oxygen here, we have an oxygen here. So you would not be able to tell automatically where your coefficient needs to change. If you change it here, then that means you change your copper. If you change it here, you change your nitrogen. And if you change it here, you're changing your hydrogen. So you would not be able to know where you would have to change the coefficient to change your oxygen. So the better thing to do now is to focus on the nitrogen. So the nitrogen, here we have a 3 and here we have a 2. So automatically we know that this coefficient has to be bigger. And even if it's 1.5, then it's going to be 2 plus 1.5, which is 3.5. That's not what we want. We know that we have to deal with double numbers. We have to deal with a whole number. So instead of it being 2, let's just change that automatically and change it to 4. Make your life easier. But that will change the numbers that you have here. So here, this is going to be 4 hydrogens, 4 nitrogens, and here 12 oxygens. And don't be intimidated because when I first started balancing chemical equations, when I used to see big numbers, bigger than 10, I used to automatically think, okay, I lost my way, this is not correct, I need to go back. Just trust your process here. Now, copper is still balanced. Now, your nitrogen is not balanced, your hydrogen is not balanced, and your oxygen is not balanced. Okay, so remember what I said here. Usually we want to go with the numbers that are even, that are smaller. So in this case, we're still going to focus on hydrogen because now we have to, that's easy to find out. What do you need to do to 2 in order for it to get to 4? Meaning the question is, what would you have to multiply 2 by in order to get 4? So the easiest thing obviously would be 2 times 2 equals 4. So I have to change my hydrogen. So this is going to go and it becomes 4. So 4 hydrogen. Now my oxygen changes. So instead of you crossing and multiplying, I just want it to be a little clear here. Let's count my oxygens again. Oxygens here, this is a 6. Here it's 2. Here it's 2. So it's 10. Okay, so this is balanced. This is balanced. Now, nitrogen is still not balanced. Oxygen is still not balanced. But remember what I said. You want to deal with the numbers that are even and smaller. Now, it would be easier to deal with the 4 and the 3. But the thing is that 4 doesn't go to 3 easily, and 3 doesn't go into 4 easily either. But 10 and 2 does. So, in order to get 2 more oxygens, I need to know where can I add 2 in order to balance out this equation. Now, hydrogen is balanced. The H2O, the water molecule, is balanced. Let me just highlight this really quick. This is balanced. This seems okay. And this is balanced, meaning that the copper is okay. So the only thing I know left is that my nitrogen is not balanced. And my oxygen is still not balanced. So that means the safest thing to do is change this coefficient. So in order for me to get 2 more molecules of oxygen, I have to add 2 here. So now this changes everything. My nitrogen becomes... Now what I have to do is change the nitrogen dioxide molecule. So here I want to show you guys, if I add a 2 here, I erased it, then that changes everything. Now that means that I have 2 nitrogens there and 2 here. So that is 4. And then I have 4 oxygens. So instead of me crossing everything out, let's count the oxygens again. I have 6 oxygens. Excuse me, that was such an exaggerated 6. I have 6 oxygens from here. I have 4 from here. And then I have 2 from here, which is 12. So the numbers should be, just want to put a nice, or actually we can do this together. We can count together here. Now that I feel comfortable, right? Everything is balanced, the coefficients are done. I have 1 copper, nitrogen, I have 4, hydrogen, I have 4, oxygen, do I have 4 or do I have 12? Remember, the 4 goes to the hydrogen, to the nitrogen, and to the oxygen. So I have 12. Copper, I have 1, nitrogen, I have 2 here, nitrogen, I have 2 here and 2 here, so I have 4. Hydrogen, I have 4. And oxygen, I have here 6 plus 4 plus 2, which is 12. I do hope that this video was helpful. Remember, when solving any science or math problems, yes, there are rules and different ways that are being taught to you guys, but remember, there's nothing wrong with thinking outside the box. Our greatest thinkers were always outside the box thinkers. So never be scared to question or challenge or maybe even suggest a different way to solve a problem. I did want to let you guys know that there is a contest. on my channel, there's 3 ways that you can enter the giveaway for an Apple iPad Pro. You can enter on my YouTube, Instagram, or Patreon page. Remember, you do have to subscribe and follow. Give the post or video a thumbs up or a like. Share this post and leave me a comment. Let me know your name. Are you in school? Do you work? What's your dream job? What's your goal? Let me know your dreams and aspirations. I always love to hear from my subscribers. I wish you much luck, and feel free to check out any of the other videos on chemistry, science, or any other topic that you wish to see on this channel. Have a good one.